Okay, ladies and gentlemen, welcome to the seventh and final video for Section 3 of Chapter 1 of your Algebra 2 textbook from McGraw-Hill. Again, this section is a very important section of Algebra 1 review. We're talking about solving linear equations, which is something you definitely should know from Algebra 1, but we're reviewing all of the finer details. This final video will cover how to take a word problem and write and solve an equation. Okay, so all of these questions are modeled after questions that have been seen on standardized tests over the last few years. We are going to solve them, and I mean, there's really not much more to say about it. I mean, we're going to be solving word problems, basically. So, our first example here says the amount of revenue in dollars, Y, that Mary earns from selling X posters is given by the equation Y equals 4X. The cost of producing X posters is given by the equation Y equals 1/2 X plus 280. How many posters, that would be X, does Mary need to sell so that the cost and revenue are equal? So we have two equations here, a cost equation, which is Y equals 1/2 X plus 280, and a revenue equation, which is given as Y equals 4X. Please notice that both of those equations are in terms of Y dollars. If we want to know when the cost equals the revenue, we set those two right sides, 4X and 1/2 X plus 280, equal to each other, and we solve for X. So our process says clear fractions, so we're going to do 2 times each thing. Which will cause the 1/2 to cancel with the 2 in front of it, giving a 1. We'll multiply that out, which gives us 8X equals X plus 560. Then we will subtract an X from each side. Now don't be that guy that doesn't realize there's a 1 there. That's 7X equals 560. And then divide by 7, which gives us an answer, X equals 80. Now this is a word problem, so the expectation is that you are giving a word answer. You would say, Mary needs to sell 80 posters. The expectation is that you are answering the question that was asked with a complete thought, which probably means one sentence. All right, let's do another one. Next weekend, Lindsay wants to attend either Carnival A or Carnival B. Carnival A charges $6 for admission and an additional $1.50 per ride. Carnival B charges $2.50 for admission and an additional $2 per ride. Write two equations that represent Part A. Write two equations that represent the total cost of attending each carnival and going on X rides. Then use your equations to determine the number of rides Lindsay can go on so that the total cost of attending each carnival is the same. Explain how you determined this answer. So, each carnival, Carnival A and Carnival B, is described in terms of price in the problem. Carnival A charges $6 for admission and $1.50 per ride. Folks, that is information that you can use to write a linear equation. So for Carnival A, we have a $6 admission fee, that is an intercept, and $1.50 per, that's the key word there, per ride, which indicates that $1.50 is the slope. So we can say Y equals 1.5x plus 6. That would be the cost of attending Carnival A. Carnival B is described in the next sentence. It says, Carnival B charges $2.50 for admission and an additional $2, and again, there's that key word again, per ride, which tells you 2 is your slope. y equals 2x plus $2.50 to get in, or 2.5. Now this is exactly like the last problem we did, in that we have two carnivals. We're asked to figure out when their costs are equal. So we are going to set the right sides of those equations equal to each other. Now when we do that, we need to clear the decimals out. So we're going to multiply every single term of that equation by 10. When we do that, the decimals will clear, and we will have 15x plus 60 equals 20x plus 25. Then we isolate the variable by moving the variable to one side. Say we subtract 15x. And while we're at it, we should move the number to the other side by subtracting 25. That causes us to have a 35 equals 5x. Then we divide by 5. And we get 7 equals x. Now we need to go back and look up here and make sure we know what x is. X is a number of rides for which the cost of these two carnivals is the same. So we could say Lindsay, it would help if I could spell Lindsay, could ride 7 rides to make the cost of each carnival the same. And that is a complete thought that answers the question that was asked. Lindsay needs to go on 7 rides to make the cost of the two different carnivals the same. Now there is a part B to this question in the notes. It says Lindsay wants to go on 5 rides. Determine which carnival would have the lower cost. So to do that, we need to copy our Carnival A and Carnival B equations over. Carnival A is y equals 1.5x plus 6, and Carnival B was y equals 2x plus 2.5. Quick check to make sure I didn't forget something there. 1.5x plus 6 and 2x plus 2.5. Good. That 5 rides, what we're going to do with that is an x value. So we're going to evaluate each of these functions when x equals 5 and figure out what the output would be when x equals 5. So we're going to evaluate those down using order of operations. 1.5 times 5 is 7.5 plus 6. So we're looking at a $13.50 cost for Carnival A. And for Carnival B, we would have 10 plus 2.5, or a $12.50 cost for Carnival B. So it says, which carnival would have the lower cost? Carnival B would have a lower cost for 5 rides by $1. That does it for the section 1-3 notes. Thank you for your patience. We have one section that we still have covered in class to record.